Welcome back. Well, we're having a look at the surface area of the tank, and so we want to understand these word problems, don't we? Because these are more like what the test will be like, and certainly these will be the challenges that you'll get in the harder work in Maths 1. So, the total surface area of the cylindrical tank, including its top and bottom, is 10 pi area. So the total surface area, that's the thing we've got to process in the first instance. The total surface area is 10 pi metres squared, okay? So if we take a net of this, a net is a geometric description of this. What we'll have is a rectangular part, that's the body of the tank, and off the tank we will have the top circle and the bottom circle. We will have both of those. Now, does it say including its top and bottom? So this is very important because some of them are like a cylinder, like a can, and some of them are like a cup where it's only the bottom. So it includes the top and the bottom. And it says the total area of this particular one, that's the surface area. So I could write up here surface area net, couldn't I? Surface area net. So the surface area net, and we're told 10 pi metres squared. So that's question information. And then it says find the formula for the tank surface as a function of the tank's radius and height. So we've got to find this bit. We've got to find this bit and surface area, so I better put surface area, so that would be surface area. Find the volume of the tank. The volume of the tank can be found according to this one. Use the answer from 1 to represent V as a function of one variable. So there we are. Well, we know basic geometries have to be converted into functions so that we can generate a particular thing. Alright, now the area of a circle is pi r squared. So that was easy, but there's two of them. Now circumference is the round bit. Circumference is equal to 2 pi r. Now that will be the length of one side. So the circumference, this length here, is 2 pi r. Very good. But there's two of them, isn't there? So that's a length, so that's all right. And to get the area, we need the height. So the area of the rectangle will be the length times the breadth, or the length times the width. So in this case here, it'll be 2 pi r h. Now we're not finished because we've got to add them together. So we've got to add that to that to that to get the total surface area. So the surface area will be 2 pi r squared, very much, 2 pi r squared, plus the thing in the middle, which is the rectangle, 2 pi r h. Ta-da! So that's our first equation. Okay, find the formula. 1. Tick. Done it. So we've made the net of the surface area and built it up as an equation. Now it's telling us the volume of the tank here. So what this is asking us is to use the volume relationship. Okay. Now this is a function in terms of two variables, isn't it? And so this is S area, and we could put it like this, and just putting X, we put R, comma, H. That's how we'd show it was two variables. You'll learn how to deal with those in Maths too, but here we just want to have the one variable. So what we can do, we can go on a bit of a information gathering thing here now. Because we know this is the answer, okay, what we can do is we can use both equations to help us make a substitution. Now, it wants one variable only, so we'll have to make a decision at some point. But initially what we're going to do is assign this 10 pi. So 10 pi is the surface area, is equal to 2 pi r squared plus 2 pi rh. Pi rh. Very good. Now, so we've got our equation. We want to rearrange for, let's say, h. So this is this old algebraic thing, make h the subject. Oh, really? Do I have to? Yeah. Because we're going to substitute h into v. And then we'll have everything just in terms, we hope, of, see, we'll substitute it there. We'll sub it in. Hopefully then we'll have v in terms of r. So let's see if we can do that. All right. So what can we do here? There's a pi and a 2 in every term. Oh, so algebraically, we can divide by 2 pi. So let's do that. So we get 10 pi. Well, that was interesting. Didn't recognise initially that 2, oh, well, this was unexpected, wasn't it? Didn't expect 2 pi to be cancelled out. But they're all one in disguise. So in actual fact, that's exactly what's going to happen. All the pi's will cancel. All the pi's will cancel, one in disguise. These guys over here will also cancel, so we're just left with one on the top, one on the bottom. This one's a bit trickier because 2 goes into 10 5 times. So we've got nothing on the bottom. We've only got 5 over this side. And we've got r squared plus rh. Very good. All right. So what we can do is perhaps move the r squared term over, minus an apple. What you do to one side, you do to the other. So we'll get 5 minus r squared is equal to rh. And then finally, we can divide by r. So we divide by r both sides. Now be careful of this one, because that's a split fraction. And just swapping them around for the fun of it, I can write, because they cancel, h is equal to 5 minus r squared divided by r. Now you can't just go willy-nilly crossing across there, you've been taught that, so please don't do that. Okay? Now, v is equal to pi r squared h. So we're going to substitute that one in there. So we're going to get v as a function of r. Now we're moving into calculus territory. Pi r squared. We better put a bracket because it's got some algebra in it. Wow. Okay, now this is a product. So this one here, I'll just put this. Now we can see that the 1 times r could come out, and I might just do that just because I don't want to confuse you about how I'm crossing that out. But the r can come as 1 times 1 over r, and we can still have our algebraic rule obeyed because that was a product and that was a divisor. So the divisor overrules, doesn't it? So it can be brought out as a times. Okay? So that's a little bit tricky. You might have to get your head around that. If we'd split the fraction, I couldn't do this. Oh, well, if we'd split the fraction, I still could do it. But the 5 on r would be there. So it's better that I bring it out like this. Okay, so this bit here is the same as that bit there. All right, what you notice is they cancel. So we've only got the 11, the pi r, 11, pi r, and then whatever we had in the brackets. Now that can be expanded, of course. And so we'll do that next. As treat that like a single term, one expansion, two expansions. So we're going to get 5 pi r minus pi r times r squared is r cubed. So we've got our calculus style function, and we can now do calculus on this. And it's all in terms of 1. So we had to do a lot of work. You'll find that these geometries, look, once you get used to them, they kind of repeat. So it's not like it's a whole new thing every single time. Once you do 10 or 20 of them, you'll start to really lap into it. All right, we're not done yet because we've done 2. So that was, as a function, 2. Tick. So once use calculus to define the dimensions of the tank, which maximize its volume. So what does that mean? We have to take the function, we have to take its derivative and set it to 0. So the first thing we'd better do, you put the double derivative there, mate. What are you doing? Single derivative, please. Single derivative to 0. So let's do the single derivative. VR dash is going to be equal to, in terms of r, this is like 5x. 5x would be 5, so the constants are left. 5 pi is a constant in this case here. Well, it's always a constant, but 5 pi r was just going to leave you with 5 pi for this first term. This one over here, the 3 is going to come out, so we're going to get minus 3. The pi will remain. We will have r2. So that is our derivative. Now we want to set this up, so we're going to have our old solve. Now what does this tell us again? When we solve this version, it tells us where m is 0. It's going to give us an r value where the gradient is 0. So now we're really thinking, because it's a volume and it's a can, it's not a graph, it's a cubic, and oh my. Okay, so it's a lot of work to think that through and say what's going on there. Okay, so what we're going to do is the first thing we can consider is that we can divide through by anything that's common, so we can divide through by pi. Now this is a bit tricky. I'm going to highlight that, so that's a bit tricky to do that. But basically what it'll mean is you'll get these cancel. Okay, you'll get these cancel. Can you just divide through by pi? 0 divided by something is still 0. So by dividing through by pi, we've managed to eliminate pi as a constant. Okay, so I'm going to undo. And just for the fun of it, I'm going to put the r squared over here. Now, of course, what that means, I might just do that in another colour and just leave the pi's in. I want to show you something there. So if we divide through by 3 now, that's undo. We'll get r squared is equal to 5 on 3. Now, of course, we undo that. Undo, undo. And we'll get r is equal to plus or minus square root of 5 on 3. So at those 2 points, we will find m equals 0, which are stationary points. Now, whether they're turning points or what have you, we'd have to check for that. Okay, so at r plus or minus 5 on 3, we will get, now we don't know what the function is because the function itself is a pretty dramatic one. All right, this is a cube of a type. All right, so I'd have to put it into Wolfie to see what it looks like. Or I could test some values, but we're solving this problem rather than doing a curve sketching problem. So we're not going to continue on with all of the things that we could check. But we do want, so that's our first port of call. We have two radii, plus or minus √3, and they are where we will find m equals 0. Now, the next thing we need to do, is the second derivative test. I want to check those values in the second derivative test. Because it seems to me that these two values, one of them might give us a max and one of them might give us a min, so we'd better check that. So we'll do the second derivative, which would become, the constant goes, and we simply get minus 6 pi r. So if we check our second derivative at √5/3, using our function notation, then we'll have square root 5/3, and so we would get, so I'll use my calculator again, so minus 6 pi, so 5 divided by 3 root, take the square root of that, multiply that by pi, multiply by that 6 minus, so we get minus 54. Okay, so that thing of emphasis there is minus approximately 54, minus 54. And so what that means is that 0.4, that is a minus, so it's concave down. So that positive root is a max. Okay, it's a max. So the second thing I want to do is check this at minus √5/3, which was the other x value. So I have minus 6 pi minus √5/3, but remember that that's a times. So now we're going to get minus times a minus, which will be a big plus, approximately 54.141. So that tells us that this is a min. Okay, so this is a min. So the one that we want to choose for the sake of answering the question, in order to maximize the volume, we could minimize the volume. In order to maximize V, we use the radius positive 5/3, which itself approximates to, let me just put that in, 1.29. And then I think it will want the h, will it? Use calculus to find the dimensions of the tank. So we've got r, now we better do h. So to calculate h, we just use the other equation. So previously, h was equal to 5 minus r squared, so we're going to use that one, over r. So that's going to be equal to 5 on r, splitting the fraction, minus r squared on r. That's an easy cancel. So it becomes 5 on r, or r to the minus 1, times r. And if we do that calculation, we'll get approximately 2.58. You've got to watch your decimals if you. So there are our two-dimension values that we could put on our cylinder as having a radius and a height. So r would be this one, and the height would be this one. Okay. Now, of course, we can check the volume. It didn't ask for the volume, but we could then put the volume in and compute that in the regular way. Okay. So we could do it either way, either with r, or we could use the VR function that we resolved in terms of r. So what was that? 5 pi r minus pi r cubed. 5 pi r minus pi r cubed. Or the other thing that should work is our regular volume equation, because we have both maximised r and h. So either one should work for a max. Okay, at those two values. So I'll leave you to put those in and see if that's indeed the case. All right, so that's taken us a little bit. Now, one of the things I did up here, I just wanted to go back, and I said I'd do it in a different pen colour. I just want you to see what happens if we do actually just rearrange this. So if I take my 5, I'm not going to do this, right? 5 pi minus 3 pi r equals 0, so undo. Just do one side, you do the other. So I get 3 pi r squared equals 5 pi. And when you divide by 3 pi, look what's going to happen. R squared is going to be equal to 5 on 3. Why? Because the pi's are one in disguise. So whether you do this initial step or not, don't puzzle over it too much. You can just go ahead and do your normal thing, and r would be equal to plus or minus the square root of 5 on 3. It'll still come out the same way. It's not necessary to do every maths thing that we do in a certain way, but you've got to find the one that fits for you sometimes. Just as long as they're correct algebraically and logically, mathematically correct, then you can go ahead and do that. All right, so I will see you soon.